So make sure you have highlighters. I will have at least 2 different colors. Okay, you ready? Normal distribution is a probability distribution that is symmetric around the mean, showing that data near the mean are more frequent. Data near the mean are more frequent in occurrence than data far from the mean. In graph form, a normal distribution will appear as a bell curve. Okay, a normal distribution, in essence, when you translate that to a graph, you should see a hat, a Mexican hat, or a bell curve. Okay, the mean indicates the location of the curve along the x-axis, right? So I kind of already did what I'm doing here with highlighters, but right, the mean gives you the location along the x-axis. The standard deviation indicates the scale. Watch this. I'm going to use a different color because we introduced standard deviation into the mix, right? Standard is the scale of the curve along the x-axis. Maybe let's highlight x-axis as well. So mean is the location, standard deviation is the scale. How so? A large standard deviation will stretch the curve. This is exactly the same as way back when I introduced standard deviation, that one page that talks about standard deviation, right? So nothing new here. A small standard deviation will squeeze the curve and it will be a steeper curve. We'll continue. Symmetry indicates that half of the values are below, right? And half are above. No news there. Examples of data that follow normal distribution. So not everything is normally distributed in life. Don't think that. But a lot of things are. Examples of that. People's heights, right, are normally distributed. If you collected enough heights of people, you would find that, oh, most people fall in this category. You have that steep average, and then you'd have some shorter and some taller, right? Birds hatching, right? The time they hatch in the spring, there's like that peak, right? It's birds hatch, more hatch, but you'll get that peak and then it goes back down. Worms coming out or bugs coming out, right? Hatching. You kind of want, right after the birds hatch, you want the bugs to come out as well so they can survive, right? The time of the year that does are in heat, right? So does, deer, right? They usually start the mating process in the fall, right? So there's like that peak time. Traffic around a certain time of the day. The COVID admissions, right? Like there'll be this peak. They'll observe the peak in there as well. So a lot of things are normally distributed. Weight, intellect, how smart, like your IQ score would be normally distributed. Doctors use normal distribution all the time to make predictions. Okay, so let's talk about, this is the bell curve labeled, okay, where remember we're doing the same thing. Frequency is still along the y-axis, and then the data that we collect, it could be years, it could be meters cubed per second. Remember that we've done a bunch of different things that goes along the x-axis. So let's see what we know about the bell curve. You see this weird little, this is mu, and you're like, what is that? It's also known as the average. So go ahead and put X bar over it. And notice that to the right of the normal distribution curve, you have 1 standard deviation, 2 standard deviations, 3 standard deviations, and this is positive because you're going to the right. If you were to go to the left, there's 1 standard deviation, 2 standard deviations, 3 standard deviations. And the standard deviation, that number, is going to make this go further apart or closer together. So don't think this is static. It seems like it, but it doesn't, okay? What we know is this. Watch this, go up here. We know that within one standard deviation, like if we consider from here to here, the chances that data will fall in there is 68%. And we split that evenly, so this little slice here is 34, and this slice is 34 as well. So whenever we find that height, let's say it's meter 65, 1.65 meters is the average height of a certain city. And then they calculate the standard deviation. So let's say the standard deviation is 2 centimeters, right? So you subtract 2 centimeters to get to here, add 2 centimeters to get to here. So people between these heights, you would normally expect 68% of the people to fall in there. 34% will be a little shorter than the average, 34% would be a little taller than the average within one standard deviation. If you go back 2 on either side of the mean, you are at 95%. Can I just say something? These are estimates, right? These are not exact. We will do an exact calculation down the road. If you go 3 standard deviations, so can I ask you to grab something that really stands out? This is like what we're focusing on. This is our average. That's the peak. That's where we focus on. That's our average. That's where most of the points will be at. And then so if you go 3 standard deviations to either end, it's 99.7%, which in some questions, they will just refer to this as the majority. The majority of cases are between this and this height. Right? So you know the question is actually saying 99.7%. So these are the 3 numbers you need to remember. Okay. Another thing I will tell you, if you take 95, right, and you take away 68%, because we already know that goes in here, you take 95 minus 68, where's my calculator? 95 minus 68, and you split that in half, you get 13.5%. So this slice gets 13.5%, and this slice gets 13.5%. But if you were to add up all the slices so far, you would be at 95%. Okay? And then there's a little bit left, these 2 here. So what I'm going to do is I'm going to take 99.7, subtract 95 from it. That represents 4.7%. I'm going to split that evenly to both sides of the curve. So that's 2.35%. You need to know these. It's a little small, but you can make it, right? 2.35%, 2.35%. Some of you are amazing at writing small. I don't know how you do it. I wish I could, but I just can't. So this is 99.7%. What about the rest, Mrs. Dirksen? Because we know that there's usually 100% of data, right? We collect all of it. Well, the rest falls outside of the 3 standard deviations. So we go 100 minus 99.7, and we split that in half. So 0.15% of data, and I just couldn't make that fit. So I'm just going to go arrow 0.15%, and same on the other side. Just go an arrow pointing to that. That's 0.15%. So all together, we do have 100%, but we tend to say that, hey, most data will be here. And there'll be a little bit left over outside, okay? I will leave it there. So the only homework that I have for you, nothing to do with this, because you're not ready yet. I want you to go to page 12. So that's the one before. This is your homework. Okay? So you have different athletes that played 10 games. Is this basketball? I think so. Doesn't really matter. But for each player, you're going to find the range, the mean, the standard deviation. You're hearing this, right? And then you're gonna answer these questions based on your findings. And I will post the key online. And if you didn't know how to answer it, I want you to copy whatever I have on the key onto here. Okay. Thank you guys.